Okay, so this section is about transformations of new functions from old functions. What does it mean? So far, we talked about the essential functions. For example, y is equal to x is equal to x squared, x cubed, and polynomials, and power functions, and exponential functions, logarithmic functions, etc., etc. So these are the essential functions we discussed. Now what we are going to do is we are going to create new functions by using these essential functions that we learned. Alright, so we call them old functions because they are like common functions that we use all the time. Now, so how do we do that? So we have some motion, such as, just a sec, let me. Such as translations. So for example, you can move the function, the graph, to the right or to the left or up or down. Okay, you can squeeze the function or you can enlarge the function. Okay, you can shift up and down. All right, you can do all these things. And we have this, for example, translation, which is y is equal to f of x plus c. You are translating the function by c units towards along the y-axis, okay, because you are changing y, okay. So this is, for example, y is f of x is shifted up by c units, or you can shift it down by c units if you subtract c, or if you want to shift it to the right, you have to subtract c from x, okay? And if you want to shift it to the left, you have to add c to x, okay? So you are changing x if you want to shift it to the right or to the left. If you want to shift it up or down, you have to change y. So therefore, you're adding to the f plus c, f minus c, okay? That's the idea. Okay, then we have stretching and reflecting as well. Okay, so how do we do that? You just multiply f. So first let's see, you don't see it here, but for example, if you have an f and if you just multiply it negative, the x by negative, you're going to get a symmetric function along the y-axis. Okay, f y is equal to f of x and y is equal to f of negative x, right? If you remember, for the even function, what do we do? If f of x is equal to f of negative x, then it's an even function, symmetric with respect to the y. So you can, it is kind of the same idea. So y is equal to f of x. On the other hand, f of negative x is going to be symmetric to this. Okay, the same picture, but on the negative side. Okay. How about y is equal to c times f of x whenever c is bigger than 1? So what you are doing is you are enlarging y. Okay, this f becomes enlarged, okay, here. So because of that, you are stretching. You are stretching y, okay? You can consider like an elastic band. You're stretching it by multiplying with a number, positive number bigger than 1. Okay. All right. So this is just vertical and horizontal stretching and reflecting. For example, this one, very last one, it's the reflection of the f about the y-axis. You are reflecting it, f of x, f of negative x. For example, f of x, negative f of x, it's a reflection about the x-axis. You're reflecting it about the x-axis. And so this is stretching the graph horizontally by a factor of c, if you x over c. Okay? Then if you multiply x with c, it is shrinking the graph of f because you're enlarging, but we take c greater than 1, right? Okay, you are all of a sudden increasing x with a number, So, okay, because of that, it's shrinking the graph. Similarly, but shrinking horizontally, this is shrinking vertically by a factor of c. But if you want a vertical shrink, you have to multiply f with 1 over c, because 1 over c is less than 1. C is greater than 1. 1 over c is less than 1. That means the y values are going to be shrinked. Okay? So this is it. And if you multiply by a factor of c, f of x, it is stretching, because c is a big number. Let's say 5 times f. 5 times f is going to be a stretched version of f, of course, right? Okay. These are some illustrations for cosine x. So we know what this red one is the cosine. 2 times cosine x is going to be vertical stretching. You are stretching cosine, okay, vertically. But on the other hand, 1 over 2 cosine x is going to be, okay, stretching horizontally. You're horizontally stretching cosine. Similarly here, what is this? It's again cosine, but here the red ones are cosine, okay? So you're horizontally shrinking by multiply cosine 2x, shrinking horizontally cosine x, and stretching horizontally cosine x here, okay? Okay. So here are some given graphs. Y is equal to square root of x. I told you to learn y is equal to square root of x. It is this graph, right? Like this. Okay. So this is you are changing the y value. You're subtracting -2 from y value. That means you're shifting the graph of this graph by 2 units down. And this is shifting the graph of this y is equal to square root of x to the right by 2 units. Okay, translating it, shifting, okay? The negative square root of x is you are reflecting along the x-axis, okay? Because of you put negative in the front of f. And then you are multiplying f by 2. That means you're stretching vertically. You're making it larger, bigger. And this, it's a reflection along the x-axis, okay? So let's see them. This is our well-known square root of x. And then, okay, this is square root of x minus 2. So this was square root of x. You're shifting it by 2 units down. And then this one is shifting square root of x to the right by 2 units. And this is a reflection, because square root of x is here. It's a reflection along the x-axis if you put negative x in the front of f. And this one is you're multiplying by 2, f by 2. It's going to be stretching vertically. So it's getting larger, okay? And y equals to negative square root of x, it is a reflection along the y-axis, because square root of x is like this. It's a reflection along the y-axis. Okay. Alright, so these are the explanations you can read. You can take the combinations of the functions. For example, you can take the difference of functions. These are the operations that you do. Addition of functions, subtraction of functions, multiplication of functions, division of functions. Okay, you can do all these. And you create new functions like that. Okay, for example, f times g is f of x times g of x. F over g is f of x over g of x, right? That's what it means. For example, you have x squared over x minus 1. This becomes a rational function because it's a polynomial over a polynomial. What's the domain? Domain is going to be everything except 1, because the denominator cannot be 1. This is the composition of two functions. Like you have f squared of 2u, and you have g x squared plus 1. And if you compose them, you get square root of x squared plus 1. Composition of two functions is going to give you new functions as well. Okay, that's it. This is explaining the composition of two functions. It says find the composite of functions of the two. But if you compose in this order or this order, you may get a different answer. Okay, the order in composing is important. So F compose G is gonna be, okay, let's see it. F compose G is gonna be x minus 3 squared. On the other hand, G compose F is gonna be x squared minus 3. So these are two different results. So when you compose in different orders, you may get different answers. Okay. All right. You can compose more than two. You can compose 3 functions together if you want. That's what it says, and it's the end of this slide as well. Okay. Let me get to the other slide.